Good morning, one and all. This is Padmavati. I'm working in Department of Computer Science and Engineering in the College of Sri Venkateswara College of Engineering, Bangalore. And today we are going to see about the topics on segmentation. And in that, uh, we are going to see region-based segmentation. Region-based segmentation in the sense it comes under region growing, region splitting, and region merging. Before that, we will see the objective of segmentation is to partition an image into regions. So the main problem is in order to finding the boundaries between the regions based on the discontinuities in the gray level. So segmentation can be accomplished using threshold based on the distribution of pixel properties such as the gray level values or the color values. And for example, you consider an image R, and here you can, if you are having two different kinds of object, one is R1 and one is R2. So the background can be considered as R3. So R1 or R2 are objects and R3 is background. And there are various conditions for calculating a region growing process. So the basic formulation is nothing but your R should be the entire image, and your R can be divided into various kinds of subregions, which is R1, R2, R3 or R0 till up to Rn. And here you are having some kinds of uh, conditions. So in region growing, what we will be using, the name itself, we can understand it is a process of grouping pixels, and thereby the image region is growed. That means if you are considering an object, and the object or the image can be growed into a larger regions based on the predefined criteria. And the basic approach is to start with the seed pixels. Seed pixels is nothing but the starting pixel or the origin pixel. So from these grow regions, we can append to each seed those two neighboring pixels which have the property similar to that of the seed. For example, in my image, my color will be black. So wherever black is there, I can grow that image to a particular value. So first thing is we need to select a seed pixel, and we need to check for the similar seed pixel. And then the third step is combine the pixels based on the predicate value. So there are three steps in region growing. One is selection of seed pixel, and then check for the similar seed pixels. And third one is combining the pixels based on the predefined criteria. And the criteria may be of gray level, texture, color, and which is local in nature. So this is a major advantage of your region growing process. The next, these are all the basic formulation, that is every pixel must be in a region, or points in a region must be connected, and region must be disjoint, and local predicate for one region which is distinguished between the other regions. Next, we'll move on to the topic of region splitting and merging, which is nothing but the quadri procedure. First, here we can take a condition. First, we are going to take an input image. Then we are going to check the predicate. And after, if the predicate satisfies the condition, then we can merge the image. Otherwise, once it is condition is satisfied, we can merge and we can go for stop. Suppose if the condition is not satisfied, then we can split the image. So merging and splitting, just if you can draw and flow chart, you can easily understand. First is we need to take an input image and we need to check the predicate. If the condition is true, then we can merge the image. If the condition is false, then we can split the image. So R is my full image, and R I'm dividing it into four regions: R0, R1, R2, and R3. So if my condition is satisfied, then I can merge the image, or if my condition is not satisfied, then I can split the image. And here, for example, if I'm going to segregate this R, my R, that is my original image R, is separated into four regions: R0, R1, R2, and R3. And here I want to segregate only my R1. So R1 has been segregated as R10, R11, R12, R13, and which is nothing but the quadri. The same process can be applied. And here again, suppose if I want to segregate R11, this portion. So what I can do from here, I need to make again the quadri, which is nothing but R110, R111, R112, and R113. So like this, I can split or merge my image based on the quadri. And what is the need for representation of quadri means? See, in programming languages and all, we are using flowcharts to understand the concept from where to where we need to go the steps and all. So likewise, this quadri represents from R is divided into 4 regions, and we have segregated, we have divided R1. That means we have partitioned R1, which is changed into R10, R11, R12, and R13. So from this, we can easily understand the region growing, region splitting, and region merging. So all these will come together so that you can understand the image processing concepts, how we can segregate the image, a full image into partitioning, and then the same process can be done in reverse also. So this is nothing but the region splitting. So your region merging is nothing but the reverse process of region splitting. So here merging. So this is splitted region. So if I combine all these things, I will get this R1. So if I combine these all 4, I will get my entire image. So this is about your region growing, region splitting, and region merging with the concept of quadri. Hope you understand the topic. Thank you.